Thank you very much, everybody, for joining us this afternoon for the second in our series on creating effective data visualizations. Basically, in this webinar, we have a few little bits. The first webinar was a little bit more of the scene setting type material. So it's a little bit more theoretical, whereas this one is a lot more practical because it's going to be focusing on how do you actually work with data to create effective visualizations, and specifically the technologies that we're going to be using today are Google Sheets, which are available in Google Drive, or Microsoft Excel. So what we're going to do is we're going to have a quick review from the last webinar, and then we're going to jump into working with data. And this is where it starts to get fun and starts to get practical. When we did this webinar series last year, we did not include a section on how to manipulate or clean or tidy data. And it caused problems when it came to people actually developing their data visualizations. So recognizing that this is indeed a core skill here, we're going to go over a few tools for helping to manipulate and clean data. And then we're going to go through some best practice principles of making effective charts and graphs in Excel. And then we're going to actually practice on some charts of what do we actually mean when we do that. And then I promised last week that I would go over a couple of the assignment options, and I will explain those as we get to them. So I thought it would probably make sense to start with a quick review from last week. And I don't know if people want to jump in either on the chat box. I can monitor that over here. When I'm looking this way, it means I'm looking at the chat box, just so that makes sense. Otherwise, people can jump in on the microphone if they want to unmute themselves and ask or answer any of these sorts of questions. So the first one is, what is one key idea, concept, or phrase that has stuck with you from the last webinar? Alternatively, what is one thing that makes an effective data visualization? And what are some of the types of data visualization that exist? So why don't we start with the first or the second one? What is one key idea, concept, or phrase that you remember from our last visualization or our last webinar over a week ago? Is anybody brave enough to unmute their microphone? Or otherwise, I assume people are chatting or typing away, perhaps. So Caitlin has suggested that the framework showing different kinds of visualization between declarative and exploratory ones was very helpful. Peter has noted that the idea that data visualization can also be used for analysis is a useful concept that we hadn't necessarily been thinking about before the webinars. Those are a couple of great ones. We have one from Nicolas who suggests that you need to consider your audience and your data and which visualization will work best. So like we said last week, that's no mean feat. It's not just about the data. It's also what your objective is, what you're trying to do, who you're trying to reach with that, and maybe what your message is, or how are you going to help them to explore that sort of visualization. Looking now at the very last question there, what are some of the types of data visualization that exist? We went through a few different frameworks last week, and indeed it looks like Caitlin just mentioned one. We've got Karen who is suggesting that there's static, motion, and interactive ones, and static ones can look very different. They could be something from an infographic through to a chart. Motion are things like videos or animated GIFs, and exploratory ones or interactive ones are a little bit more complicated. Caitlin focused in on the visual discovery, which is that kind of exploratory visualization. And let's see, all the types are important. I'm not suggesting that one type of visualization is more important than the other, not at all. I'm just trying to have us have a quick reminder of what are some of the different types of visualizations that exist out there. And people seem to be coming back a lot to this particular framework, where we were talking about the declarative versus exploratory and the conceptual versus the data-driven. What we're mainly focusing on today is going to live in this box, so the everyday data visualizations that you do. And they're some of the most simple ones, but the reason that we're starting here is because it's incredibly important to get the fundamentals right. So that is why we're going to focus on this little side of things. So that's a good summary, I think, or recap from last week. Why don't we go ahead and get cracking? This is the good bit where we get to start actually working with some of the data. In this section, I want to cover just a few principles of data structure, and then take a little bit of a look at how we summarize the raw data that we might have, and how we merge a couple of data sets. So I think the first thing that's really important to discuss is the principles of data structuring. And this is important because actually for the two technologies that we're going to be working with during this webinar series, one is Excel or Google Sheets, and one is Tableau. And each of these different types of technology has a preferred style of data. So Excel or the Google Sheets, which we're using today, tends to prefer the summarized data to be able to present things. So what we have here is some data that I've worked with before from IHME, which, I'm not sure I know what it is, International Health Metrics and Evaluation Group, and they produce an annual report that is the global burden of disease. So that's a very uplifting topic, I'm sure. But basically, this is presenting the average death rate per 100,000 people across a number of different countries. So this is kind of summarized here, where we have the country, Afghanistan, Albania, gender, male, female, both, 1970, 1980, and then here you have those actual death rates. Raw data, on the other hand, is every single piece of information has its own individual row. So we have the death rate per 100,000 people here, but then you can see that Afghanistan appears 1, 2, 3, 4, 5, 6, at least 6 times already in this same data set. And it goes to 1970, so that's male, female, and both. And again, male, female, and both. So 1970 is 3 times, 1980 is 3 times. The sex is different for each single one, which means that this is then our first actual number that we're working with. So kind of flipping back to this, just so we can explore the difference now that we've seen this. This is kind of summarized or cross-tab data, where we have Afghanistan, the gender 1, 2, 3 times, and the header 1970 and 1980. Whereas in this one, for every single piece of new information, there's a new row. So Afghanistan 1970, I keep on pointing to it as if you can see what I'm pointing to. Let me use the mouse. Afghanistan 1970 male is one unique set of information, a unique data point. Afghanistan 1970 female, a unique data point. So it each has its own row. This is a pretty important concept. I hope that I've explained this okay. Are there questions or on the difference between summarized or cross-tab data and this raw data structure? Caitlin asks, which is preferred? I would say it really depends on what you're trying to do with it. There's no, one straight answer, I suppose. The basically summarized data is what you might use to make charts and things in Excel, because it's a little bit easier to work with. If you tried to, if you selected all of this data in Excel and said, boom, give me a chart, it just wouldn't work. It wouldn't know what you're trying to do. If you gave this set of data to Tableau and said, give me a chart, it will work, and we'll see that. So it's not that one is preferred or one is not preferred. It's that they kind of have different purposes. If I were structuring things for data capture, if I was doing kind of a survey, or if I was looking at how do I structure data to come in through a mobile phone or something like that, I would always try and structure my data in the raw form, because it's a lot easier to convert raw data into a summarized or cross-tab data, and a lot more difficult to pull from summarized into cross-tab, or summarized back into raw data. So in terms of data capture preference, it would be on the raw, but in order to work with it, we might have to summarize things. The 1970s data is higher figs in raw data. This is just an example data set, so let's it might have been that I've copied from two different data sets. Ignore the actual data that is in this, because we will work with this later. But there is a question. In the raw data slide, the figures are a bit confusing. For example, in the case of Afghanistan, over 300,000 deaths per 100,000. Is it on purpose, and does it have an explanation? That is a really good question. One, it probably average figures in the summarized one. That is probably true. To be honest, let's just assume that this data itself is not the exactly correct one. But we will actually be able to play with this data set, and we can answer those questions in there. So like I was saying, it's a lot easier to start from the raw data and then to summarize the data. What I've done is I've taken that whole data set, and it is available through this link. If you want to try and follow along now, you may, or you can, when we send this to you later, you can use this link to download or access the data yourself, and then to kind of follow along with this. A lot of today is going to be on an attempt to do a live demonstration. So live demonstrations have a tendency not to work properly, but we will do our very best to make sure that this all works just fine. Basically, if you click this link, it takes you to this particular sheet on Google Sheets. If you do not currently have a Google Drive account, I do recommend getting one, because it's very useful. What you should have, because this is my particular one, I have a little bit more that I can work with, a little bit more control over it. However, you probably don't have much of an ability to do anything with this. So what you need to do, if you want to follow along with this as we go along, is in the File menu, go ahead and say, make a copy. You can name it whatever you want to. You can put it wherever you want to in your drive, but that will copy this information into your own drive, and it will mean that you are able to go ahead and work on that. I see that there's probably a few of you that are accessing this data at the moment, which is really great. Can I show the URL again? Yes, I can. It's a short URL. It is bit.ly/O, capital T, lowercase dv, and the number 1. I think that actually, maybe this is probably easier if I just type that in for everybody. The idea was that's what OTTS on think tanks, data viz 1. Does that link actually work for people in there? Hopefully that will help. So what I wanted then, yes, more helpful to have it in there. I will make sure that I put that in there, but we need the different ways in case people are watching this later. Great, so what I wanted to show you is a function called a pivot table in order to summarize this. We see that we have the raw data, there's country code, country name, year. We see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, quite a lot for, I mean, this is all still Afghanistan 1970, so we have data disaggregated by age group, by a number of different age groups, by male, female, or both, and the death rate. So this does have a death rate for males of 0 to 6 days at above per 100,000 people. So I think that we would need a health expert to explain to us how that statistic is calculated. Because to be honest, I'm not quite sure how you get a death rate of more than the number of people. So I suppose the first question though is, have any of you created a pivot table before? Jennifer is very familiar with pivot table, that looks good. A long time ago for some people. Well, hopefully this will be a useful refresher anyway. And at least maybe a note that it's possible to be done in Google Sheets for those of you who maybe tend to use Excel more than Google Sheets. This is a function that exists in Excel, but also here. In order to create a pivot table, the first thing that you have to do is you have to highlight the data that you want to create a pivot table of. We've got a maybe once and not so sure. I love the not knowingly have I created a pivot table. Well, we will find out here shortly if you did it by accident. So if we select all of this data, in Google Sheets, this is in the data menu, and you can go ahead and say create pivot table. Normally, this will create a different sheet. And you can see that down here, this has created something called pivot table 4. And it was still thinking about things, but it has now been created. So this is our pivot table. And what this does is it's going to actually help us to summarize the data that we have. The important thing is that over here on the right-hand side, we have the report editor. And this is what allows us to choose what information is displayed in the pivot table over here. If for any reason you click out of your pivot table, that pane disappears, and this is true also in Excel, but if you click back into your pivot table, then that will come. Now what we want to do is we want to summarize the data that we have. And we see back in this raw data set that there was a number of countries, but we see just Afghanistan itself has, let's see if we can figure this out, just Afghanistan itself has 315 entries, oh my. So it would be really difficult if we were trying to figure out what the average death rate is in Afghanistan, for example. But we can actually, in this rows in the report editor, add the field country name. So instead of showing Afghanistan 315 times, we see over in our pivot table, it's starting to summarize the data, and we can see that we have a number of different countries in here, information on 187 different countries. That's already a big difference. For the values, the thing that we would want to add is the death rate per 100,000 people. And this is starting to give us really crazy numbers straight away. We can see it's giving us very crazy numbers. If we thought that 300,000 per 100,000 people was a weird number, then 4 million is certainly a very wrong number. Why is that? Well, that's because basically this is saying right now, effectively what this is doing, we've added a row and we've added the value death rate, and it's basically adding all of this information up into one. And apparently that gives us, in Afghanistan's case, 4.4 million, basically. So one of the first things that maybe we think this doesn't make a lot of sense, so why don't we switch it from sum to average? that might help right there. And indeed, it starts to give us more realistic looking numbers, although the way that this data is structured, we can't really work just with averages. So how can we fix that there? One of the things that we can do then is we can add a filter. So in this case, we notice that right now it's selecting all items. And in Afghanistan, there were, or in this, was it sex or gender column? I don't remember what it's called. We have both female and male. In this case, because we're using the summarized data, we want to just go ahead and only use both. So we see that already the numbers start to change a little bit because we've taken away basically what is double counting. I happen to also know that the way that this data is structured, we have each of the individual age groups, so 0 to 6 days, 1 to 4 days, 15 to 19, whatever, 55 years. And then all the way here at the very bottom, we have all ages. And we just want to use all ages. But if we click that, that actually makes it go away. The easiest thing that we can do is when you have a lot of different things to select is to clear everything and then just to select that one. So this is already looking a lot better. However, there's one last thing that we are slightly concerned about, which is that this is across a number of different years. So why don't we actually just go ahead and create a new column that has the years in it, and along the top, what we're going to do is we see 1970, 1980, 90, 2000, 2010. And we can start to see the correct death rate per 100,000 population in Afghanistan from 1970 through to 2010. Whew. How was that for people? Does that all make sense? Are there any questions on the creation of a pivot table like the example that I just showed you? Pretty good from Rosata.
Oh.
So, has somebody unmuted themselves? Nicola suggested it was easy to watch, maybe more difficult to do. Was anybody trying to follow along and able to successfully create a similar pivot table on their own, in their own drive? Great to hear, Alex. We have one question here from Peter asking, why am I using the average? Right now, it's mainly to show you that this Summarize tab has a lot of different things that you can do to actually make sense of the data. In principle, crossing fingers this works, in principle, if I switch this over to sum at the moment, because we're actually already at the lowest common denominator, you see that the numbers don't change, because basically we filtered out the unacceptable, but you see if you're looking at that data, that's not remotely close to what it is. So if you do use the average, you can say, okay, the average across years was 1,667 per 100,000 people, or if we look at the grand total at the bottom, this is now showing us the average. We can say the average death rate per 100,000 people across all of the countries in the world is 1,189. I suppose one thing that we have to be a little bit wary of in this particular instance is that this is not weighted by population or anything like that. So this is the average of each of the countries' data, not necessarily the average global death rate, if that makes sense. It's the same reason why if we don't double count this data and we say male and female, just show us the average, that is going to give us slightly different numbers. You can see that those numbers change very slightly. In 1970 in Afghanistan, it's 2,430. And if we just show both then it's 2,432. Basically, that has to do with the weighting of the breakdown of the population between men and women in Afghanistan. So you can't exactly just use that average, if that makes a little bit of, I hope that that makes sense. But it does give us a nice summarized data set to be working with. And yeah, I don't see any other particular questions on that, so I'll just say that basically the idea of a pivot table is it's going to create a dynamic summary of your raw data. And the reason that I didn't over here kind of select all of the columns and then select the data, but rather highlighted the column head and just basically selected all of the columns, was that a pivot table is always active. So if we change, for example, and that's what I mean by the word dynamic, is it's always looking at things. So if we potentially changed in Afghanistan, I'm not sure I'm going to be able to find this very easily, in the all ages section, all ages, okay, I've got it in Belgium for both. If we change that to 999999, over in the pivot table, we see Belgium has suddenly changed that right there to 99999. If you, or I'm going to undo that because that's not going to help us very much. If you select the columns and you add more rows to your data, then this will update live, which is the other thing that's really useful about it. Just one quick note in there that different programs have you create pivot tables slightly differently. In some cases, like I think in Excel, it depends on which version of Excel you're using. You insert a pivot, you use the insert menu to add a pivot table, or in some cases, like here in Google Sheets, it is in the data tab or in the data menu. And then as you're working with pivot tables, the things that I would suggest are build your pivot table step by step. Don't try and rush into it. Make sure that everything is making sense, and do sense checks as you're going along. And this is an example of where we needed to use the average rather than the sum potentially. Think about all those numbers. Don't just take for granted that raw information or those summarized numbers. And as such, don't forget about the filters. Good. I can pause again for questions, although I think that I have done already with pivot tables, so hopefully that works. If you have further questions on pivot tables, let's move those into the forum. The next thing I wanted to really quickly look at is merging data sets. So it's not atypical that we have something that looks like this, where we have, for whatever reason, in this tab, we have the death rate per 100,000 people, and in this particular one, we have the number of deaths in the final column. But what if we want to work with both things, or maybe make a chart that includes both of those numbers? I'm not sure it would make sense in this particular case, but there might be something we want to work with. Then we need to merge these two data sets. And one of the easiest ways of doing that is with the VLOOKUP function. VLOOKUP is short for vertical lookup. And the best way I can try and explain it is that VLOOKUP asks the question, what value from another table belongs in the particular cell where the function is happening? Have any of you guys done VLOOKUPs before? We've got a yes from Jennifer. Excellent. No, never, once, one time. And then you're like, I'm done with this. I don't need this anymore. Okay. The formula itself is comprised of a unique identifier in the current table, what the table range to look up the value in is, which column the new value is in, and whether or not you need an exact match or the first match. And this is an example of what that formula looks like. So the VLOOKUP formula says, okay, what is the unique cell? that is present in the current table that you're working in, but also in the other tables that you're going to be working in. This should generally be in the same row as the data that you're working in, but the other important thing is that this key unique cell, that information needs to be contained in the first selected column of the table you're looking things up in. I will show what this means in a second. The table range is where we can find the new data, the column number is where this one is, and false is at first versus the exact match. So, in this case, we have two different tabs. The first tab is death rate, the second tab is deaths. If we want to get the number of deaths on this one, let's go ahead and insert a new column. So I've just right-clicked on that and said insert a new column, and we can call this deaths. Now, we do have a slight problem because we are using raw data instead of summarized data, which is that there is no single cell that we can create here as an anchor cell that actually is unique. So 0 to 6 days happens in a lot of places, 1970 happens in a lot of places, Afghanistan in a lot of places, male, female. So what we actually need to do is we need to create a unique cell. The easiest thing that I'm going to do is I'm just going to I'm inserted a new column, and I'm just going to very quickly, the technical term is concatenate. Basically, I'm going to put together all of these cells so that we have a unique identifier. So that's the country name, I'm hitting the ampersand, 1970, the year, ampersand, age group, ampersand, gender for sex. So I've hit enter, and you can see that the output looks slightly strange. It doesn't really matter that there aren't spaces, we're just using this as a unique identifier, so that doesn't really matter. In case you weren't aware, if you double click on the square on the bottom right corner of a cell, that will fill down an entire row. So we now have this unique identifier sitting in this table. Unfortunately, we have the same problem in this particular table, so I'm going to repeat that. So I'm going to create a unique identifier by putting an equal sign for a function, and then say the country, the year, the age group, and the sex. And we have that exact same sort of unique identifier. And if I double click on that bottom right hand corner, then all of that is filled down. So now we can actually do the hard job of putting together our VLOOKUP function. So what we're trying to do is we're trying to say, basically, for Afghanistan in 1970, for the age group 0 to 6 days old in males, how many total number of deaths were there? So if we do equals VLOOKUP, the search key is our unique identifier. So I'm just going to go ahead and click that, hit the comma. The range is the table where we're looking things up. Like I said, this unique identifier must be the first column that is in our range. So I'm going to select these two, both of them. Now, index is what column is the information that we want to put there in. And if we count from this one, this is column number 1, and column G is column number 2. So we want to put the number 2. And then there is, do we want the exact match or the first match? If we put true, it will go a little bit faster, but it assumes things are in basically a certain order, which these ones are not. So generally speaking, I recommend putting false because we want an exact match. So again, we now have that. If we can see here on the deaths, okay, 19,241, 1970, yep, male. That is indeed, we can double check, that's exactly the right one. If we hit if we then double click on the bottom right hand corner, it's automatically going to fill that out. And we've now basically merged our data sets. In terms of last minute tidying for this, I'm going to hit Command or Control and the down arrow to select all of the cells that we just had. Hit Control C or Command C to copy all of them. And then just, instead of pasting them, paste doing right click and hitting Paste Special so that we're pasting the values only. And so now instead of having the formula in there anymore, it's giving us the raw numbers, which means that we can delete our unique identifying column. Okay? Whew. I have a message from Caitlin saying a technical glitch with Google Sheet, no longer having access. Make sure that you've made a copy, I guess I would say, Caitlin. You shouldn't have access to this particular one. You shouldn't be able to edit it because this is what we're using for everybody, but you should be able to make a copy. If you're having a glitch with your other one, go ahead and make a new copy, perhaps. Are there, oh, I see. If you're logged in with different accounts on Google, that can also create problems. Are there questions on VLOOKUP for using or for basically merging two different data sets? Again, if there are, Google, if in doubt, Google is indeed a friend, says Nicolas, which is very true. And one of the exercises at the end of this is actually to have a go at doing this. So if it doesn't make sense now and you're finding it as you're trialing things that it doesn't work, then I'm sure we can answer questions in the forum. So there we are. I've already demonstrated that. We're on to the questions of how to merge those sets. That's just a little bit then of a glimpse of some of the things that you can do with really large data sets and why this is great to be then putting things into data visualizations. But we definitely need to be able to manipulate the data first to get it in the right format. Of course, the next step, what we're all looking forward to, is the actual visualization part. So this section, I wanted to go ahead and make our charts great again. I've just got Alex saying, oh my goodness, it's worked. Good news. I'm very glad to hear it. It's always good when things work. And while it is great when everything works according to plan, of course there are times when things don't. So I'm afraid that the recording of the webinar cut out for a few minutes of it. So what I'm going to do right now is just quickly re-record this particular section. Sorry if it looks slightly different from the other bits that were recorded from the live webinar, but I did want to make sure that you had all of the content. So what I wanted to move on to now is making your charts great again. Before we were focusing kind of on how we manipulate the data, and now here in this section, what's really important is focusing on how to display it visually in an effective manner. So in this section, what I want to quickly talk about then is some common mistakes that you see in charts, and then an overview of some of the different chart types that exist, followed by one key process that you always need to keep in mind when creating charts, and then finally a live demonstration. So what are some of the common mistakes when it comes to charts? I will say a lot of these come from Gregor Eisch, who is a great data visualization expert. I think actually working now with the New York Times, but has also helped put together data viz tools like Data Wrapper and other things. So do check out this presentation there if you'd like. Otherwise, here are some common mistakes. One of the first ones we talked a little bit about in the first webinar, which was don't use 3D. This is an example where actually we have both charts are showing the exact same thing. On the left-hand side, it shows 1/3, 1/3, 1/3, or 33% in each case, Whereas in the one that is in 3D, although the pie slices are still technically 1/3, 1/3, 1/3, because we've skewed the perspective, the bottom bit looks almost like 50%, or certainly much larger, especially as the eye perceives, even in that 3D bit, all in one section, one part of it. So, maybe some of you are busy creating your VR experiences and you've got this virtual reality thing ready to go, in which case maybe then you use the 3D. But generally speaking, we try and keep it simple and keep it flat. One of the other things that's really important is not to go color crazy. Having too many colors can really just keep people from being able to focus on whatever the point might be. It can be distracting, really, which is what you see on the left. It's also something to say where maybe don't adhere so strongly to your brand if that doesn't make sense for your visualization. You see here in this particular one that we have an actual category that's showing up as the background color because that's what the brand is set up to do. Well, that's certainly not what we want. We want to be able to actually see the chart or see the data. So in this one, we've actually highlighted whatever the important value that we're trying to show is, and otherwise we've used things of the same hue. Just a quick note on colors, a few important things to keep in mind. A lot of times we pair colors and we think, oh, let's do complementary colors because that really is going to show some contrast. But it is important to bear in mind that if we use directly red and green, for example, that's terrible for colorblind people who can't tell the difference between the two. So generally speaking, we either use a red to blue spectrum or a purple to green spectrum in our data visualizations. It's also really useful to use, stick to the monochromatic side of things. That's not just so people don't get distracted, but also sometimes if you have colors that are of the same, that are of different hues, I suppose, but have the same gradient, which is to say the same light intensity, if you print them out in black and white or in grayscale, it's impossible to tell them apart. So you want to be thinking also about the lightness and darkness of the colors in terms of how much light they use. One other quick thing to note is that depending on how much of the color you're using, the warmer colors here at the top, the reds, the oranges, that sort of a thing, tend to appear slightly larger than the cooler colors, the blues and the purples. So that can be overpowering. You need to think about that a little bit as you're choosing colors. One of the other important things to do is maximize legibility. In a lot of cases, people are just glancing at our data visualization. And so instead of these skinny columns that we have on the left, the general rule of thumb is that if the width of a column is X, then the gap between the columns should be half of X. So this is twice the width of this as a good rule of thumb to kind of really present that data clearly and to show what belongs together. If you have a group, then that should just be half the size, and then that should be the same sort of gap between two clustered columns. Another important thing to pay attention to is the order that your data is presented in. A lot of times we just keep things in alphabetical order because that's the way maybe the data itself comes in. But we actually really need to be thinking about telling the story. If, for example, you're using the same few data points throughout a report and they appear again and again and again in a series of charts, then it's incredibly important to keep them in the same order. If, however, you're trying to use just one chart, for example, to tell a story of whichever is the greatest or whichever is the smallest, then actually sort them in ascending or descending order based on the value, which is what we have here on the right. Another thing that we can use which we consider either a mistake or I suppose can be done deliberately, use these powers for good though, is not scaling to 0. So the example on the left-hand side, and this is particularly true for column and bar style charts, is basically manipulating the way the data is presented. It's not presenting it with integrity, and it's over-accentuating the differences that might exist between those four categories, whereas the one on the right goes all the way to 0 and actually does present a more accurate picture of maybe not as big of differences. So as a general rule, you should always scale to 0, especially with column and bar charts. This can hold true to line charts, but there are some exceptions. So this, I think, is a really good example of where scaling to 0 is really not effective. So what we have here is the average annual global temperature in Fahrenheit. So apologies that it's an American style scale here. But it even makes the point more clearly, because what they've done is they've said, oh, we need to present our annual average global temperature scaled to 0 and then up to 110 degrees. Well, what is 0 in Fahrenheit? Absolutely nothing, no meaning. It does not even like Celsius, where at least that's the freezing point of water. So the chart on the left is maybe used by Republicans or those on climate deniers on that side of the argument and say, look, there's no climate change. But actually, we also know that what do scientists say is going to be a problem? How many degrees does the global average temperature need to change for us to have a huge problem? Well, it's about 2 degrees really, 3, and we're really having some problems. So if we're scaling for 110 full degrees, you're not even going to be able to see that change of 3 degrees. So we really need to, this is a good example of where you need to really be thinking carefully about what is the point that I am trying to make, and therefore what makes the most sense. Another one that's really important is actually directly labeling the lines on a line chart, or directly labeling as much as possible, not just on line charts, on bar charts, in pie charts, in any sort of chart that you're actually doing. Because what we have here on the left, it's really difficult potentially. Okay, in color it's not so bad, you can tell that that red and that teal are very distinct, but if we put that in grayscale, the red and the yellow might look quite similar, and it might be very difficult to say, okay, series 1 is which one, and look down at the legend and say series 2 is which one. So there are 2 things that we can do to help improve that. If you don't have very many lines or very many data points, you can actually include markers, so that can help you show where different points are, but also distinguish between the different lines. But one of the other good things you can do is label things directly. So putting which series is which, and you'll notice that I've even colored those appropriately. Definitely one that you should be paying attention to. One of the other ones is where we start getting back into the argument of Edward Tufte on the data-inc ratio. And what we have is a lot of superfluous information that's actually sitting on this chart here, in terms of in this case, you might not even need the axis labels if you have the direct labels here, and you don't need the grid markers necessarily. One thing you might see that's becoming a lot more typical is actually putting the grid markers basically in the background color overlaid on top of the columns, so that can help people count if you want, but then also including the values right there is very useful. So always, always, always edit and make sure that you're telling the message and telling your story as clearly as possible without any superfluous information. Not highlighting the message is a common key one. So in this particular case, I mean, this is obviously just made up data. What's really important, or what we want people to look at, is that D is 4.5, so it's the biggest. We could have just as easily highlighted the 2.5 and saying B is the absolute smallest, but this is using a similar hue but different gradients of the data, of the color, to really highlight things and make things pop. And then one of the worst offenders that I often get is chart titles. I think one of the things that's really important when we are, especially doing something that maybe if you're thinking it's going to appear in social media, is to help people find the message of that particular chart. So in this case, we have a chart that is showing youth unemployment data in this. We see highlighted Greece, Spain, and Germany, but I can tell you that it's in different European countries. So it's not unusual to get a title that is going to generically say youth unemployment rates in Europe. Okay, but that's not really giving us a message, and it doesn't really tell us why some of these ones are particularly highlighted. So any ideas of a good, a more descriptive title perhaps for this? What might be a message that we're trying to see here? Giving everybody a bit of thinking time. Or is everybody going to put the same title, that it should just be youth unemployment rates in Europe? Well, if we want to give something about the north-south divides, suggests Nicolas, or the differences in youth employment over time in Greece, Spain, and Germany. That's, Peter, a very descriptive title, but quite on the long side. Karen, we have suggest youth unemployment high in Greece and Spain, for example. So, okay, one of the examples that we put was youth unemployment on a historical high. We see that that doesn't quite work because you have places like in Germany where it's not. So you could then have a more descriptive title that says youth unemployment divides Europe. But you definitely were on the right track. You don't have to be as specific as saying Greece, Spain, and Germany necessarily. Jennifer has suggested something more specific like youth unemployment in Greece and Spain is 6 times higher than in Germany. That could really work if that is what you, if you want to be that specific, it can help. But the thing that you want to guard against is having still a 2-line sort of title. But you can still use, I know I've worked with a lot of researchers before that get a bit worried when you don't have something that describes exactly what the chart is showing. So you can say in a subtitle, seasonally adjusted unemployment rates for under 25s, but you still want the main message to be there in the title. In terms, before I go on to this last kind of not choosing the right chart type being a common mistake, I would say that Nicolas pointed out that not citing the source is a common mistake, and I would also agree with that. In terms of not choosing the right chart type, we had a couple of examples of this in the WTF Viz. This is a good example where we have Lithuanians said 99%, this is all, again, made up data. I don't know what 99% of Lithuanians think. 20% of Belgians and 10% of Moldovans. Obviously, that pie chart does not equal 100%. Pie charts should only be used in part to whole relationships. So we can go ahead and take that into a bar chart that shows 99% of Lithuanians think something oh so very important. In terms of the different types of charts that exist out there, this is coming from the graphic continuum, which is the link I shared in our very first discussion in the forum. The different types of data that you might have include distribution data, time series data, categorical data, part-to-whole data, geospatial data, and relationship data. Just to really quickly show you, I definitely highly recommend looking in more detail at those. Distribution data, we have things like histograms, which show how many in each of a set of different categories. Very typical is a box and whisker, or one of my favorites is actually a fan plot, which shows a number of different potentially future scenarios, for example, or yeah, done a lot with scenario mapping. Time series almost always is in a line. I don't know if any of you guys have heard of spark lines. That is something that Tufte talks a lot about, basically kind of thinking of data as in the concept of words. And so that is something that is word size that just kind of gives you a quick indication of how things are moving. I've seen that a lot now in, if you're online and you're seeing reference to a stock, for example, Yahoo, Apple, whatever it is, Google, some non-technology stock, they have a little spark line kind of showing how it's performing that day. Is it up, is it down, that sort of thing. I've also seen it on, I think, Google Trends does the same sort of a thing. Stacked area might be useful in that, and I like the stream or the history flow are quite common ones as well. In terms of categories, we have things like bar charts, column charts, stacked ones, 100% ones. One of my favorite ones are Sankey diagrams, which kind of show, okay, if you have this much from at the beginning, some of it has gone into this category and some of it has gone into this category. You might have seen things like that before. Waterfall charts are good when you're used a lot in accounting to show, okay, we've added this and then we've taken away this and this is the final result. Slopes are very common, as are dot plots, or sometimes those are called dumbbell charts that kind of show the difference between like a starting point and an end point. Another one that people like a lot in infographics these days, or what this one refers to as an isotype chart. We're not going to go into how to develop those today, but if you're looking for a quick and easy way of doing that, you can either use a tool like Pictochart or Infogram. Both have those isotype charts built in. In terms of part-to-whole relationships, we have pi and the donut, which is with the center taken out. I've already shown you an example of the nightingale or rose plot, and tree maps are a lot more common these days. Geospatial, obviously, we do lots of mapping. The most common sort of maps that you would use is something called a choropleth, which shows the different rates as a gradient of a particular color. Cartograms, there are a few different tools that are available to help do that. But there's also a map with charts, or a point map that maybe the points depend on the size of something, is another very typical one. And then finally, there are relationship charts where the scatter plot is a really common one. And I've seen a lot more chord charts that are about as well. So I can send an example of those. That is something useful to think about. And what I really like about the entire graphic continuum is, if you're struggling because you don't know quite what I should do with my data, looking at this and saying, okay, I know that I have some sort of mapping data. What might I be able to do with that? Or I know that I have a categorical variable. Is there something interesting with the gauge or a pyramid chart, which is what you might use to compare males and females, for example. Any tool to do geospatial is one of the questions that are there. As a matter of fact, yes. And why don't I go ahead and pop over and show this to you right now. We've done our pivot table in Google Sheets. And one of the things that I really like about Google Sheets is that they make maps super easy, a lot more so than Excel. So if we go ahead and just select that, for example, in this particular case, we're just going to use the death rate from 1970. And if you do insert a chart, it's suggesting a histogram. That's not what we want. If we flip into chart types, we see that one of them is the map. This is either a choropleth map or the bubble map. And we can go ahead and customize that. So the minimum, so where the death rate is the lowest, we have a light color. Where it is in the middle, it's slightly darker, and where it is the most, it's the darkest. And we insert that, and straight away, we've just got a quick choropleth map that shows us death rates in 1970. Happy with that, Alex? Can you do maps with unique values on Google? I'm not sure I understand the question, Jennifer. Caitlin has asked, how did I do that? What was the first step? The first step was the first step was to create our pivot chart. But if we then just, all I've done is I've selected a cell, and I've selected the first two columns, and then I've hit, if you hold Command or Control, that will go down to the very bottom of your data set. And we don't want the grand total map, so we go just then click the up arrow one more time. We have all of that data selected, and I've said insert a chart. And that's pulled up this chart editor where we can now say different chart types. So with death rates, it doesn't, a choropleth map makes a lot of sense. If we wanted to do, here, really quickly, if instead of the death rate, we got rid of that value and we said the value, oh shoot, we don't have the raw number of deaths. Otherwise we would add the raw number of deaths in there. One other thing to note with this is that Google requires a specific kind of country code. So in this case, we clearly don't have data for South Sudan that are showing up. And I have to apologize that I know that that's South Sudan. I'm not sure what country that is that's not showing up. Greenland is not showing up. I don't even know what that is either. But you might need to be careful about that. Can't see the chart editor when clicking on insert, says Nicola. Make sure that all of your data points are there. Insert, it doesn't show up until you hit chart. You have to hit that chart, and then a chart editor should show up. Oh, is it maybe put it somewhere else? One thing is that even if you insert on Google Sheets, even if you insert a histogram, which in this case just really doesn't make any sense whatsoever, there's quick edit mode, but if you hit this drop down, there's something called advanced edit, and here that will also bring up the chart editor, so you can change the chart type to all of these different types. Now, they do have scatter plots, they have bubble charts, they have your bar charts, column, all sorts of different things. It is really worth, I think, exploring Google Sheets for this. I think they do a little bit better and a little bit easier, some of these ones, than Excel. So we can just quickly change that to the map or to the bubble chart. At the bottom of it, you'll see go to the older version and then options pop up. I'm not sure what that is in reference to, Alex, but this is the advanced edit that might be helpful. Good. Okay, well, so there we go. We've got a demonstration of a geospatial chart. It's like I knew that you were going to ask me for something like that. One thing then to say in terms of using any of these is to basically do three things to improve any of your charts. The first one is to edit, edit, edit. Remember that you're trying to tell a story with this. Get rid of the chart junk as well. Use color appropriately, we've talked about, so really use it minimally. Try and highlight using colors to direct the eye in the right place. And make sure you've got a good title. If there's anything that I want you to take away from today, it is edit the chart, color it appropriately, and title it appropriately. And that is one of the things that also a really great data visualization expert, Amanda McCulloch, has been on about. So I will send a reference to her as well, because I think that is a really important thing to keep in mind. So how do we do that in practice? No, come back. Demonstration using Excel. So we do have this. I've now shown you this for Google Sheets, but some of this I think is slightly easier to demonstrate in Excel. So I'm going to copy our data set, or just the results of that pivot table on death rates, and hopefully, well, paste it in there. Okay, here's one I made earlier. Sorry about that, but this is exactly the same thing. It is the countries and the year and the death rate. Now, one of the first things that we notice is this is time series data. So what sort of a chart would we want to use for time? Nicolas says line chart. That is correct. A line or potentially an area chart. So if I'm now on the cell again, I'm holding down the shift key, right-clicking the arrows until I'm there, and again, hitting the down arrow. If you hit Command or Control and the down arrow, that goes to the very bottom of the data. Peter notes that line is a basic option. So let's start with the basic option. I have 158 different countries, and we have this data set. One of the things that we notice straight away is that it's not giving us time series data, it's giving us the different countries there. That's the wrong way around. So we need to switch the row and columns. Wow. So here we are exploring things. This might throw up some interesting stories, but generally speaking, this is probably way too much information to put on one data visualization. One thing that might be interesting is that in Korea in 2000, there could be that there's a data issue there that maybe we need to look at. Or maybe they had just a really high death rate in 2000. In Haiti in 2010, this begins to point to a story. I think we all know that that was when there was the earthquake, and so sometimes you see these spikes in death rates that start to make sense. But having said that, again, that's still a lot of information to put on one particular chart. What is some way that we can start making sense of things? Well, we need to start summarizing our data. One way we can say is, how has the death rate overall changed over time? So maybe if we say, what is the average of all of the countries? In principle, this is not the same as the global death rate, but it's not too bad. We can say, use the average function, and in our brackets, we can go ahead and just select all of that. And then in this case, if we double clicked down, it wouldn't fill anything. So we need to use that and drag that across. We can, if you click here and then hold the shift down and click there, that gives us, highlights that entire row. And then you would need to hold down Command and get these header rows in. But this might be one way of doing it, basically, is what does it look like on average? Oh, it's not like this for some reason. Okay, let's try this again. This is always the joys of live demonstration. You never know what it's going to throw up. Okay, so we could see that, for example, the death rate has gone down on average over the years. How people would recommend, quite typically with this amount of data, is something known as a trellis plot. So you would put lots of different of these plots together right next to each other so you can get an overall picture. To keep it on one sort of chart, I'm going to work to add some of the summarize the data a little bit. So I'm keen to kind of know the range that we have of the death rates per 100,000 people. And so I'm going to find the maximum, and I'm going to find the minimum of that data. And again, we're going to drag that along. So basically, if we have the max, the min, the average, my mouse trackpad is being a little bit complicated. And then let's say we also add in one country for comparison. So we've got Afghanistan in there as well. If my trackpad doesn't want to stick, thank you. Let's insert a chart. This right there starts to give us a little bit of an idea of what needs to happen. Now, based on those principles before, edit, color appropriately, and title appropriately, what could we do to potentially improve this chart? Any thoughts? Take off grid lines. That might be one thing that we could work on, yeah. So in order to do that, you would click into the grid lines, you see that they're all selected, and you can just hit delete, for example. Yeah. Other ideas? Definitely direct labeling of the lines is incredibly important. In particular, in this case, we have Afghanistan and the average, I think, is useful to see. So if you just normally select that, you can see that if you right click, it says add data labels. we don't necessarily want labels on everything. So let's undo that. If you click again, you see that it's highlighted only that one single point. So if you then right click and you see that that says add data label instead of add data labels plural. This is incredibly important. That's what we want to be using. We want to add a data label. Why it's done that there, I do not know. Let's try this again. Click into the line, click that one, add a data label. That's playing ball at this point, so that's all that is selected. And say add data label. I'm then clicking on that label, double clicking it twice, so it's only doing it, add the data label. And here in the label options, we're saying the series name. Now, one of the things I'm sure that you are noting is that that's kind of overlapping things. If you take the plot area and drag it over a little bit, that will give you some room on the right side of your chart to work with. There was a question from Jennifer asking, do you have to label each line separately or can you do them all at once? I'm very sorry to tell you that you can select a whole series and you can add a data label to everything in a particular series, but because you're working point by point, I'm afraid that yes, you do have to do this point by point. Basically, you have to do it one at a time. Sorry. Again, when it comes to potentially using color here, we're going to do some more with color in a second, but one of the things that I like to do is to actually highlight that text and in a similar way that you would anywhere else, go ahead and make that, well, that's filled the box rather than the font itself. Sorry, this one. Go ahead and make that so that there's no doubt, basically, that what we're looking at is that. What are other ways that we could potentially improve this chart? We have a question here saying, does it help to increase the scale of the axis so the lines have a wider gap, or is that misleading? It might help. I think that what we are, and it might also depend on what we can do in terms of what the title is. Nicola has suggested we add the chart title. In this case, we could say something like, Afghanistan death rate is nearly an average, in which case we want there to be a very narrow gap at the very end. We don't want to try and over-exaggerate things one way or the other. So that's an example of a title. Do people have any other ideas of what a potential title might be? Decreasing death rate in Afghanistan. Or something like death rate in Afghanistan is now has decreased to the global average, let's say. Something like that, that gives a very descriptive thing. Somebody is saying that we can remove the legend. So what I'm going to do is I'm going to click that and I'm hitting the delete key because we've already directly labeled these particular lines. Absolutely. And so in that case, we might be able to then take the plot area a little bit bigger so that that's all maximized down there. If you're not aware, in the banner, I guess they have up here, you can actually add or remove different elements of the chart as needed as well, just in case you need another way of accessing things rather than this here. Yes, we have a few more suggestions on title, which is great. I'm going to go with this for the time being. There are a couple of things that I would say that we still might want to think about. We know that this is the max and the min. We have taken away the legend at the moment. It might be worth, for example, putting these on a different axis or making them basically, one of the things that we can do is if we change the chart type to make that an area, okay, this is famous last word, we're going to try this, and then if it's not going to work, then I am apologizing in advance, but that appears to have almost worked, so thank goodness. And instead of having this one be yellow, if we select it, and in this particular case, we can format the data series over here and say that the fill should be, instead of the yellow, make it the white, which is the background color. We now have this that's displaying slightly different information, which is the min and the max in kind of a light area background color. Did people see how I did that? So I just selected it and I changed the chart type of that particular series. We then might want to insert a text box that says, you know, something like global range, if you particularly feel the need, or you might be able to explain in text or something there. The one other thing that I would say that we don't have is that the death rate is there, but we don't have a little bit more description. So I would say that this is the the death rate per 100,000 people. And we'll make that more of a subtitle, so we'll just go ahead and make that a little bit smaller. Any questions on all of that? Hopefully that makes a bit of sense. We've only really gone through one particular one, which was the line chart example. We can do bar charts and things and improve things, but basically we have in the exercises for people to be able to do an attempt to work on that. So why don't I go ahead and also say a little bit about the different assignments that are available. Like I mentioned in the last webinar, to complete the course, you need to do only one of 4 different exercises. And the first 2 options are tidying a data set for use in a visualization or refining a chart using Excel or Google Sheets based on what we've just been talking about today. We'll get to the other ones next week. But in terms of tidying a data set, I have put together a sample data set for you. If you follow that link, and I will be sure to share this in the forum and everything in a lot more detail. In principle, this should pull something up. Wait. Okay, some of you might be aware that the UK has just had a general election. We naively were calling it the 2017 general election. It might turn out to be the first general election of 2017. But what I did, therefore, was I was curious to see a little bit about the population and the number of voters in each of the different UK constituencies. So we have Aldershot, Aldbridge, and we have Barking, things like that. That is the population in each of those different ones by age group. And then we have the number of electors in each of the different constituencies. So what I've tried to do is I've tried to keep the data just like it came from the Office of National Statistics. And what I would like you to get to is to merge these 2 data sets using VLOOKUP and to then be able to answer the question, which UK constituency has the highest share of electors in their population? So that's the first one. That is data from the ONS. I'm not sure if it's officially census data. It might be some of their other experimental statistics, but basically it is data from the Office of National Statistics. The reason I don't think that that's census data is because they have that on an annual basis, and the census, I think, is once every 10 years in the UK. The second exercise is instead of pulling up in Google Sheets, I've lost my mouse. Come back. There we go. This should download an Excel sheet for you. And what I've done is, so this one is saved in Dropbox. We have a lovely couple of set of charts. One is the population breakdown of Bermondsey and Old Southwark, and the other is how the electorate has changed between 2015 and 2016 in all of the different constituencies. So your job will be to figure out if this is the best way to, when I say improve or refine a chart, the actual idea might be, is this actually the right chart to be using? So that is for you to be thinking about. Like I said, you only have to submit one particular exercise for this entire thing. However, it might be useful for you to go through the whole process and actually have all of the different ones there available, just as practice. So those exercises will all be doing on the 29th of June, which is, I was going to say that's next week, but it's not quite next week. If there are there any questions on that general exercise? I expect that maybe as you start looking at the data more, you might have them, in which case, please feel free to add those questions into the forum. So with that, I will say thank you very much for joining us this afternoon. I was going to say this evening. Is it this evening or this afternoon? I suppose it depends on where you are. Maybe for some of you it's the morning. But if you have any other questions, please let us know. But hopefully today what we've seen is how to start manipulating some data, and we've started working on creating some really basic data visualizations, in particularly a line chart, and we even did a sneaky little map on Google Sheets. So now you can say you know how to create a choropleth map and maybe even know what that is. Next week, we're going to build even more on this and work with Tableau Public to create some interactive dashboards where the different charts actually help change what is presented on the other one. So I hope that has been very helpful for you and that you have taken away some charting best practice tips. Like I said, the one thing that I definitely want you to remember is to edit, to color appropriately, and to make sure that you have an appropriate title on your charts. So beyond that, unless there's any last little questions, which feel free to pop in the chat box. Otherwise, I will say thank you so much for joining us today, and I hope that you have a lovely week. You can join us next week at the exact same time, next Thursday at, what do they call it, 3 p.m. UTC, so 4 p.m. in the UK, 5 p.m. Central European time, and elsewise. So glad that was helpful, and look forward to seeing you next time. Have a good one.